All right, this is Mr. Wyrick. I'm going to kind of talk you through this set of notes right here, the 3.8 lines tangent to a circle. So this is not going to be as complicated or as heavy on the math stuff as when it comes to the lines intersecting with a circle, but there's still a decent amount of math to do, so let's take a look at what's going on. So how many times do lines intersect? What are all the possibilities for intersecting lines and circles? So what we saw through most of yesterday was we had a line that went through a circle, and we had that line intersect the circle twice. It's possible to make a line that goes outside a circle and it wouldn't intersect the circle at all, but it's also possible to have a line that's going to be what we call tangent to a circle. It's going to intersect it one time, and that's what this is. I apologize for the print down here being in, I don't know, Chinese, Korean, something. If a line is tangent to a circle, it intersects the circle one time, okay? And that place there is the point of tangency. So what else we know about the tangent line for the circle is it forms a right angle. Okay, so if we can form a right angle with that point of tangency, then we know we've got things in the right direction, and we'll kind of work from there. Slide number 4, would there be a way to place the sprinkler so that the sidewalk is tangent to that sprinkler? So yeah, we just need to move it down, and we need to decide what our point of tangency is. So, you know, if we find one where it's like, oh, this point right here, and we can move it down, would it still go above? We'd probably need to move a little bit this way, but to where we have a radius that comes up and is perpendicular here, and it makes a point out here that is one of these points right there. So we could move this in a number of ways. I would say probably the easiest thing to do would be to shoot for this one right here. So we adjust this to where we have a perpendicular line that goes there and makes that circle all the way here to where we're tangent to that sidewalk. We're touching the edge of the sidewalk, but we're not watering the sidewalk instead of the grass. That's a real world kind of situation. You wouldn't need to write the equation in that real world situation, but this is a real world setup for this situation. So how do we find the tangent lines? Finding the tangent lines and point of tangency can be made easier if we have horizontal and vertical tangent lines for the circles. That's pretty simple. But the radius is always the radius. Remember, wherever that tangent line is, we have perpendicular lines. Okay? So the radius of the circle at the point of tangency is perpendicular to that tangent line. We can use that. Remember, perpendicular lines are going to have opposite reciprocal slopes. So if we do something like this, we can use point slope form. If we have a radius that has a slope of -1/6 coming out like this, and it's going to go through that 0.34, our perpendicular slope would be the slope of +6. So if we need this, it would be y minus y1, so y minus the -4, so y plus 4 is equal to my slope of 6 times x minus x1, so x minus 3. You could definitely use Desmos to try to help you out and make sure that what you're looking at is going to be an actual tangent line for this practice stuff today. So here's our sample problem. Draw a line tangent to the circle whose equation is x minus 2 squared plus y squared equals 20 at the point 0, 4. Write an equation for this tangent line. So again, we're going from here to here. So I would find the slope of this. We're going down 1, 2, 3, 4, and over 1, 2. So this is a slope of -2. Okay, it has to be that way. Remember, we calculate slope going from left to right. So we're going down 4 over 2. 4 divided by 2 is 2. And because we're going downhill left to right, this is negative. So we have a slope of -2. That means our tangent line needs to have a slope of 1/2, and it's going to go through 0, 4. That's y equals 1/2 x plus 4. Okay, we don't really need to do anything crazy with this one because this is the y-intercept, so we can just write it in slope-intercept form and not have to worry about point slope. Okay, your assignment for today is going to be the 3.8b worksheet. It's going to be on Schoology. Just make sure that when you work your way through it, you get that either submitted or make sure you know where it is. When I return after spring break, we'll kind of go over these things before we move on to the next lessons.